Hello, everyone. I'm Ihab Ilyas, and today I'm very happy to share with you our system Saga, a platform for continuous knowledge construction and serving at scale, a system that we developed at Apple for the last 2 years with an amazing team led by Rekatsinas, Vishnu Konda, Jeff Pound, Xiaoguang, Mohamed Soliman, and a very talented set of engineers, scientists, and ontologists in the Knowledge Graph platform team. Saga builds a large-scale, consistent knowledge graph from a variety of sources that contain possibly contradicting information in different namespace and different representation to put it into a target control vocabulary or an ontology that allow us to serve this graph to our customers via either views and slices of this knowledge for people to use in their own applications, or to enable services and machine learning based services that expose the knowledge in this graph, for example, semantically annotate unstructured text with entities or query understanding, for example, that are natural language. And obviously opening an endpoint in which you can query the graph in real time for the large number of queries that we get daily. The green line that we see there is an extremely important piece to keep this graph not only constructed and consistent, but also recent by incorporating all of live streams of live information relevant to our knowledge and augment this graph with this real-time information without compromising the consistency of the graph. The details of how we do this Lambda architecture is in the paper, but these are the main principles in building Saga. The high-level architecture of this complex system include multiple boxes, most notably graph construction piece that takes these sources and build a graph, and a graph engine piece that exposes that graph in multiple views. And building this graph requires publishing this graph in what we call an edge serving that realize a real time or a live version of this graph that you can hit it with query workload. And the blue lines on the right-hand side are our machine learning services that serve both in batch mode and in live real-time mode. So hopefully I'm gonna talk a little bit about the technologies involved, such a system, and some use cases in this presentation. The technologies involved should not be surprising because in order to build and do KG construction, you're probably expecting data integration work, which is true, a lot of governance, cleaning, and deduplication, entity linking, transformation, inference, and that comes at the core of building the graph. But also we care about integrating stream engines with this to deal with our live streams and NLP and information extraction system to achieve coverage, because not all the information we need are coming on a silver plate in structured format, and we need to go and play fetch and get what we need from unstructured representation of this information. The last layer is extremely important because it's an expensive layer of involving humans judiciously to curate portion of this knowledge and hopefully focus on the most important piece, the high value fact, the most visible entities. And we use a lot of tooling to be able to recommend what humans should look at so we don't spend a ridiculous amount of money on validating parts of the graph that either for sure accurate or nobody cares about. So here's an example of what I mean by putting everything in one source, or the single source of truth of knowledge. So source A and source B talk about the same entity, in this case, Connor McDavid, the hockey player, and they represent them. They represent that entity in different namespace and also in different portions of information, and putting them together into unified representation according to the target ontology in a rich format capable of even absorbing more data later is important to expose this entity in machine learning models for services, KG index for lookup, or either views for other people to see it. So an example interaction will be, in this case, how many goals does McDavid have in a query? And the machine learning models will help us understand that natural language query and turn it into a structured lookup of the information in the graph. So I need to land on the correct McDavid. And once I get the structured query, I should be able to answer how many goals he scored. So how to do this is by building that large-scale knowledge graph that we're extremely happy to increase it by orders of magnitude in the last 2 years, just by focusing on scale, incremental processing, and continuous processing, so that new platform transform the size and the shape of this graph, but also reduce the time it takes to build it and to onboard new data sets to it. So today I'm going to focus just on a bunch of anecdotal examples of the activities that we do in the knowledge construction, in the graph querying, and also in the semantic annotation that happens on top of this graph. So as you can imagine, knowledge graph construction requires a target graph data model. In this case, we're using an extended triple, a simple model that have facts and entities with facts, predicates, and predicates about predicates to allow us to group some of these facts together using something like RDF blank nodes. And it's not much more expressive than that, and that allows us to do a lot of the activities that we need to do without adding complexity in the reasoning in the system. To construct the graph, you can imagine how many adapters and transformations we need that are a little bit customized to the sources. But once we have that transformation happen and everything look like an canonical input to our construction platform, then schema mapping, entity linking, entity fusion happen to construct that unified graph. The sources are very heterogeneous, from structured, well-curated data partnership sources to extracted knowledge and public information that requires hand-holding and quality assurance. So an example of the activities other than the bread and butter dedupe and linking is object resolution, and I will highlight it here. So if I get an entity that Neil Young, who's born in Toronto, and Toronto is represented in the input as a string, what we want to do is to get rid of these strings and use object resolution service, which is an ML service that does semantic annotation of text, in this case, the property of the birthplace, and link it to the correct node Toronto, which is the actual city, and that will allow better analysis of and better understanding of that input. So once the graph is constructed, we need to query it, and in order to query it or expose it, we use a graph query engine that is responsible for taking the constructed graph in its kind of probabilistic format and expose it in multiple modalities that are all different representation of that knowledge, either as an entity index, text index, or a vector database of all the graph embeddings for every entity and fact we do to power downstream machine learning models, for example. And we allow people to declare these views and incrementally maintain them all the time as a core principle in building Saga. Other than these views that are kind of happen in a batch and incremental way, the graph is also exposed in a live KG version that allow us to serve billions of queries a day with less than 20 millisecond SLA at the 95th percentile latency. And for that, we needed to do our own DSL called KGQ. So these are path queries that allow us to get facts out of the graph, and sometimes path and multi-hop queries extremely fast to be able to serve workloads that you might be familiar with that have this strict SLA. Details of the query processing in the engine are in the paper, but I'd like to take the time to talk a little bit about semantic annotation using machine learning services and a bunch of use cases that put all of these into coherent stories. So one of the things that we focus on in semantic annotation is the ability to land on long tail entities when the context dictates so. So when I say Virginia Heffernan was born in Hanover, I would like to leverage what I know about every Hanover in the graph and their connections, and what I know from the context to land on the correct Hanover as opposed to the more popular Hanover, Germany. To do that, our named entity recognition and disambiguation stack is built on top of the views, the view engine that I told you about earlier. In this case, it uses two specific versions of the graph. One that exposes every entity and its aliases and its names in a map, and one that have feature map for every entity. that allows to know the types, the related entities, and what have you. And in this case, once we get a mention, we can get all the candidates of this mention, all the Hanovers in the graph, all the Michael Jordans in the graph. And then using a transformer-based model, we can land on the correct, or at least rank these candidates accurately with the most probable entity that you mean. That transformer-based contextual re-ranker, as I said, use the context, the mention, and that rich representation of the graph. And by leveraging the KG context, entity types, relations, we do extremely well on disambiguating tail entities. So we increase both kind of precision and recall with very high threshold of confidence, because the system is also able of rejecting the linking exercise by saying we don't have enough confidence to link it to any entity in the graph, not to confuse downstream applications. So this a slew of services, from constructing the graph to building a graph query engine that exposes it in a different way, to build a bunch of machine learning services that can do annotation. We power a bunch of use cases. The obvious ones is question answering, where KG power accurate question answering, as I showed earlier, by using the context and direct application of the entity disambiguation model. We land on the correct Michael Jordan when I talk about students, as opposed to the basketball player, and the correct movie, not the book, for Harry Potter and the Sorcerer's Stone, by knowing that I'm asking about who directed that. And this is really key in transforming the correct question that you mean when you interact with the graph. KG semantic annotation also enable us to annotate whole web documents, for example, that we see, to do better search, better recommendation of content, by tagging all of the mentions of entities that we know about in the graph by the correct entities in the graph. And that will allow us to have much richer representation, which what's in the document, and also allow us to do rich experiences to put in front of the user when you're reading a piece of text, for example, and you see everything is clickable to dig into the knowledge that we know about these entities that mentioned in the text. Lastly, an interesting application that might not be obvious to all of us is how important that when you ask about a question that have multiple answers, how to get a stable ranking of the answers of this question, so you don't get a random set of facts every time. In this case, if I ask about occupation of certain celebrities because they're interesting people, you will find their Wikipedia page mention many things that they do, but you would like to get a singer or performer for Taylor Swift before you get, for example, a teacher or an anchor woman or something that she did for fun and it was mentioned. And in this case, we embed the whole graph into an embedding space and transform this ranking into a structured query as a nearest neighbor search. And the trick here is how to embed the whole graph at scale without using a cluster of tons of GPUs for weeks. So we're using Marius technology for fast embedding of the knowledge and scalable embedding of the knowledge graph. And that allows us to train that embedding-based model in less than a day on a single machine with a couple of GPUs, and achieve really good results in this use case. So hopefully I shed some light on the activities involved in building such a graph at scale in production for many use cases that expect this graph to be available in a variety of modality, either as a data store or as an embedding store or as an ML service. They interact with it as an endpoints or querying it directly for question answering systems. And harmony between KG construction, graph query engine, semantic annotation has to happen. I'm very happy that I shared the effort of a big team for the last 2 years. So thank you for listening in, and please come with questions and comments. Thanks for having me.